Now here it says PMQROS is the cross section of a play area in a park. PQRS is a rectangle and PMQ is a semicircle. O is the midpoint of RS. OP is equal to OQ, which is 15 meters, and angle POQ is equal to 40 degrees. Right? Now it says use pi as 22/7. Right? Notice that once I hear about pi, we're going to use some formula for the circumference or area of a circle. So let's look at what the question is asking us. Determine the value of angle OPQ. Now let's locate angle OPQ. So OPQ is right here. So this is the angle we need to find. Now, notice also that OPQ is an isosceles triangle. Remember that two sides are equal. OP and OQ, they are equal to 15 meters. Right? So we have an isosceles triangle here. So therefore, if we call this side here x, this side must be also x. Right? The two angles must be equal. So we have 2x plus 40 is equal to 180. So therefore, if we make transpose for x, we're going to get 2x is equal to 140. We subtract 40 from both sides. We divide both sides now by 2. So we get x is equal to 70. So therefore, angle OPQ is equal to 70. Right? 70 degrees. Let's put our degrees. Now, here it says calculate the length of OR. So let's look for OR. So we need to find the length OR, that is right, this section right here. Now, in order to find the length OR, what we can do, we can use the Pythagoras theorem because we have a right angle triangle here. So here's a right angle triangle. So that's the right angle triangle. We have one side, which is 14.1, and we have the next side is 15 right here. So we need to find the unknown side right here. So let's call it y. So therefore, in order to find OR, we're going to say OR is equal to the square root of 15 squared minus 14.1 squared. Remember, we're finding a short side of the right angle triangle. Therefore, it must be the hypotenuse square minus the other side square, and then we take the square root. So enter that in our calculator. The square root of 15 squared minus 14.1 squared. And that gives us 5.1. Right? So OR, the length of OR is 5.1. Let us move to the next part of the question. It says calculate the area of the shaded portion of the diagram. Right? So 3 marks. Let us go back to the diagram. Now, the shaded portion of our diagram, right? The area of the shaded portion of our diagram is going to be the area of the triangle plus the area of the semicircle, right? Now, the area of the semicircle, we know how to find that. We already have the radius of the semicircle. The radius of the semicircle is the same value we got for OR, right? So we have a semicircle with radius 5.1. So we know how to calculate that area. We also have the triangle with angle here 40, and we have sides 15 and 15. We also know how to calculate that. Right? Now let's go down here in the space provided. So the area of the shaded region, so area is equal to, let's put shaded region. Area shaded region is equal to area of semicircle plus the area of the triangle. Now the area of the semicircle, we're going to use pi r squared divided by 2, because the pi r squared is the area of a full circle and we're using a semicircle, so it's pi r squared divided by 2. The area of the triangle now is going to be half 15 times 15 times the sine of 40 degrees. Now let us compute this. So we're going to use pi as 22 over 7. So it is 22 over 7 times r. We're getting r as 5.1, and then we square it, divide that by 2, plus half of 15 times 15, we can write that as 15 squared, and then sine of 40. Now let's enter this in our calculators. So we have 22 over 7 times 5.1 all squared. So let's equal. So we get 81.745. Well, let's keep this value and we're going to divide it by 2. This is going to give us 40.87. So this is 40.87 plus, and then we're going to take 0.5 times 15 squared, and then we say sine of 40, and that gives us 72.31. So 72.31. So the total area now is adding these two numbers. So it's 40.87 plus 72.31. That gives us 113.18. Let me use the red. So this is 113.18. Alright, so that is the area of the shaded region. Let's look at part C. It says find the perimeter of the cross section PMQROS. Let's go back over to our diagram. PMQROS. So PMQROS. So we're finding that perimeter. Now remember that the perimeter is the total distance around. So therefore, we have 14.1 here already. So this side is also 14.1. Now this side, the OR is 5.1. Therefore, this side is also 5.1. So we can say that this is, all of this SR is 10.2, right? So SR is 10.2. Now the next piece of information we need to find the arc length. We need to find the arc length PMQ. So this length we need to find. Right? Right, so this is pretty easy, because we know the circumference of a circle already. The circumference of a circle is 2 pi r. Now, if we have a semicircle, then it's going to be half of this. So it is going to just be pi r. Right? The two cancel each other. So therefore, we can go ahead and calculate the perimeter. So it's now, let's go back down to the space. So it's going to be 14.1 plus 14.1 plus 5.1 plus 5.1, and then we have plus pi r. We know what r is already. R is the 5.1. So If we enter in our calculators, let's write down 22 over 7 times R, which is 5.1. So let's put that in bracket. Now, so we can add these in our calculator. So 14.1, we have 2 of it, so times 2, plus 5.1, we have 2 of it, times 2, and then plus, can use our bracket, 22 over 7 times 5.1. And that gives us 54.4. Right? Now, let us ensure that we have our units. So our unit is supposed to be in meters. So here it's supposed to be in meters. Let's ensure that our area is in meters squared. Right? So this is the perimeter of the cross section PMQROS. Right.
So in this section we look at solid geometry. This involves things like total surface area, volume, or you might be asked to transpose a formula to find either the radius, the length, and so forth. So as we progress in this section, you will see some of the techniques and how to use reasoning skills to solve these questions. Now let's look at the first question 6. So here it says a piece of wire 61 centimeters long is bent to form a sector as shown in the diagram below. The sector of the circle OPQ has center O and radius 18 centimeters. Show that the value of x is approximately 80 degrees. In order to show that x is approximately 80 degrees, we need to use this key piece of information here. A wire of length 61 centimeters long. Using that information, the perimeter of the sector must be equal to 61 centimeters. Now PQ, we need to find PQ, which is the arc length, and we are also given the radius, which is 18. So OP and OQ is equal to 18. So right there we have 18 plus 18 is equal to 36. So that's 36 centimeters. So we can say this is OP and we can say this is OQ. So we have 36 centimeters there. Now in order to find PQ, we have to use the formula for the arc length. So PQ is going to be equal to x over 360 times 2 pi r. And if we add the OP and OQ, we are going to get plus 36 is equal to